So this week, the only thing I thought about was I was thinking about my lawn tractor again, and it's still sitting out in my garage. I keep moving it around, is why I think about it. Um, and it's that's I got to the point where I got the power steering motor bolted on with the chain drive, and I just need to put some electronics on to run that. And then to run the transmission, I've got to play a bracket on the back where I had one of the giant RC servos. In fact, this is the one here. No, it's not the one because it has a plastic arm on it. But anyway, one of these giant RC servos that so I can just bolt it on, and it's the one I'm going to use has a steel arm on this, and then I've got a connecting rod that runs from here. I drilled a hole through the back so that it goes up to the transmission, so that all you have to do is move that arm back and forth to make the transmission go. So you can go forward or go backward or stop based on that. And I'm at the point where I just need to measure how much travel do I have on that arm on the transmission. First of all, how much travel do I have so I don't smash anything? And then secondly, figure out, what I consider my top speed to be, just figure out what that angle is, and then how fast reverse I want to go and measure that. And technically, since that rod sticks out the back, I can just take a ruler there and push it in all the way till it bottoms out and measure that, and pull it out all the way and measure that. So technically, I could do that. The other thing I wanted to do, mine does not have hold on a second here, speaker view. Okay, mine does not have the foot pedals like the one Al has. The at some point when they went to a modern way to do it, they put the 2 foot pedals, so you press on one to go forward, or you press on the other one to go backwards. And mine came out just before that, and it has an arm sticking up out of the fender with a knob on it. So you just grab on that. If you push the arm forward, you go forward. You pull it back, it'll stop, or you pull it backwards, then you back up. And that's the way mine works. Which turns out, for what I'm trying to do to make it to automate it, that works out great because it doesn't have the built-in spring that returns it to the idle position. So if you set it somewhere, it should stay there with you don't have to overdrive it with your actuator. And the other thing, it's also the point where it's got a little friction brake on that. So if I push the thing 50% forward, it'll drive at that speed, and you're supposed to be able to let go of it and drive around all you want. I notice it slowly works its way back. Back when I used to use it a lot, I would, drive up and down the yard, and by the time, you get from one end of the yard to the other, thing is starting to slow down. But it's got a little a friction brake with a nut on it. So if you just take a wrench and crank down on it, it tightens up the spring, tightens against the spring. So I think I could get that so it would stay in the position where it's supposed to be, or the position I want it. Well, what I want to do is I just simply took off the connecting rod between that arm and the transmission, so that isolates the two, so that I can run the RC servo to run the transmission. And I thought if I could figure out some way to measure the position of that arm, then I could do just do a drive-by wire like Kyler. Kyler had like a Caterpillar brand tractor, a big track vehicle, and his had like a joystick next to the seat. And it's like the Danfoss stuff does, where you've got a joystick that puts out signals, and then those signals would be sent to your transmission to run the actual vehicle. And he just intercepted, he put an Arduino in between his joystick and his transmission. So he could either run, he could flip a switch and say, I want to be in manual mode, and you just run the joystick and it passes it through the transmission, works just like it's supposed to. Or you could, flip your electronic switch and say, I want to send commands from the computer, and you just bypass the joystick. So I was thinking I could do the same thing on mine, where if I can measure the position of that arm, then I just get on, flip a switch and say, I want to drive manually. So as I move that arm, I control it just like it used to work. So instead of just having a connecting rod, there's a connecting rod about this long made out of steel. Instead of having that, not all this other fancy stuff to actuators and sensors, but theoretically I could make it work the same. So technically I just get on, start it up, drive around the yard, and I can overdrive the power steering. So I can just either leave that the way it is, or if I really wanted to, because you can overdrive it, but it's more effort to turn the steering wheel, and that's going to get annoying if you're trying to mow very much. So I can either pop the chain off between the power steering motor and the steering wheel, or yeah, that'd probably be the simplest thing. Just take the chain off, and then it'll be back to just to normal at that point. So I was just trying to figure out how to do that stuff, and I just need to figure out some way to measure the I can move that arm forward and backward to control the speed, and then down at the bottom there's just a little thing that's about this long. It moves back and forth, and that's going to be the same amount of travel that's on the transmission. So I just need to have something to put on this thing that moves back and forth like that. Just have something that measures the position of that. And I've got some of those tilt sensors out of cars, tilt sensors. What do you call a ride height sensor or something? And what's the one everybody else, not Bosch, it was Delphi, I think is the brand that everybody was buying. And I found one that's actually out of a Corvette, something about the steering, the headlight, a headlight level sensor or something. And I bought a bunch of those at the surplus store, and they work exactly the same way. So I just have to figure out, if I hook one of those up to it, is the amount of travel reasonable between the two? Because again, if you push it too far, you're going to break something. And I think Matt on his uh, Cub Cadet lawn tractor, he was trying to use that sensor to measure something and he had it mounted incorrectly, and he pushed it too far and it snapped off the arm on it. So see, you got to be careful. So first of all, mechanically, make sure you can't damage anything, and then secondly, try to get it centered so you get a reasonable signal out of this whole thing. And as I was telling Al, his lawn tractor, he can take all the stuff off the top and get down to a bare frame, and he's got the transmission bolted in there and he can get to everything. On mine, they just had, it's like the old Volkswagen, the original Volkswagens, where they had a floor pan where they just stamped out the frame is actually just a stamped out piece of metal, and then they bolted everything onto that. Well, that's the way they did my lawn tractor. So I got this like 1/8 inch thick uh, sheet of steel that they've stamped out to form the frame. And there's a couple like frame rails underneath that are spot welded onto that. And then the transmission is bolted on that. So the bottom line is I can't take it apart to get down to all the pieces I want to measure. So that's going to be somewhat of a problem to do that. And I was also just pointing out to Al, if anybody wants to get a John Deere Sabre lawn tractor, don't. If you're trying to automate it, because you can't take it apart, you can't get to the pieces. So there's probably everybody else in the world has one you can take the top off and take the sides off and get down to where you need to. But mine, it does not really lend itself to that. So that's kind of where I'm at. I thought I should do that, and I might be able to like tape a piece of cardboard under there and crawl in from the side and then move it and take a marker and put marks where it's supposed to be. But that's something yet I'll have to figure out. So I guess that's all I have to report since last week. So I'll just turn it over.
On the throttle control, I know that you and I have similar servos that we're trying to use for our throttle control, but have you ever thought of a linear actuator for yours where you would get both the movement and the distance with the same device?
Well, I have thought about that, but any of the linear actuators I have are way too slow to do that. And the one I have looks like it's worked just fine. It's, I just have to bolt it on. I've had it all completely bolted on. I just haven't hooked up. It was to the point where I thought, okay, I'm ready to go, but I should hook up the wires and I should take it apart and put Loctite on all the screws. And I took the thing off and just left it off. So it's really the point. If I just go bolt it back on, it's the actuator is ready to go. It should give me everything I need. It's just that I need to know, what are the two the two extremes on the position, and that's so what I have would work just fine if I just go ahead and go out and do it.
Cool.
And also on mine, I don't have to overdrive that spring like you do, so I don't need, something really beefy. But those giant RC servos should work just fine for doing the position, and they should be repeatable enough and accurate enough that they should do what I want. So, and
Cool.
essentially those have a position feedback coming out of them. If you buy the right one, there's a pin to do that. And the older one, the one like you have that's on my steering on this thing right here. So there's a servo right there underneath the thing. And that one I just soldered a wire onto the board, and I can read that out with an A to D and get its position back out. And it's not strictly necessary, because being an RC servo, you say go to 50% and it will. And like on this one here, It's nice because you can say, set it to say, go over to the right hard stop. And then by watching the feedback, you can tell when it actually gets there. So if you're doing calculations off that, you can do calculations off the returned feedback as opposed to the signal you're telling it. So that's just more things to think about there.
Neat. Yeah, as I turn on sharing here, I continue to be well, I got to the point where I'm back out in the yard testing, and speed control is still, I don't have a very robust solution, and it's rather fragile. And at the moment in my launch file, I have a series of parameters that basically say, are you going, um, well, the parameters give me the ability to vary my speed, and I'm trying to home in on this particular position where I've currently got 314 coded in. This is the next test because I want, when I tell the servo to go to position 314, I want it to go about somewhere between a half a meter a second and 0.75 meters a second. And at the moment that's variable, but that's my next test. So to get to that point, I had to get my plan completed, and I've got that in the way that I built that plan was drive a perimeter and then use a bunch of math and code to convert that perimeter to a plan that looks like that. That's one view, but then the final view is this, where you can see the outer paths to create, what do they call that, headroom? I forgot. Headspace? I forgot. So I would run these outer perimeters first, and then I would do the stripes, what I refer to as stripes, back and forth. And that circle represents an obstacle. And so I had, the last piece that I had to do last week was adjust these line segments so that it came down close to, but not over that, over that. And so all the code to do that is in this, it's either in this Jupyter Notebook or referenced in the Jupyter Notebook, and is just a straight Python script that's out there on GitHub. But that's what I had to put another circle in there where the U-turn would start and stop, and have that move back far enough in order to give the U-turn space to finish and not, go over the real obstacle. So that was a little bit of fun programming. So I got that done.
A couple of points right there. First of all, the word you're looking for, headland,
Headland.
is what they call the space at the beginning and end of the rows.
Thank you for that.
And then looking at this here, what you could do, like, when you're driving around the outside to clean stuff up, you could just basically put concentric circles around your obstacle there to clean up the whole thing. I know when I go out driving in the yard with my lawnmower, I'm coming along to a tree there, I'll just come to the tree and just make several circles around it to get in close enough to the tree to cut it. And then just, they go around, that just leaves a circular area around the tree that I had done. So you could do the same thing here, just simply drive, when you're all done, just have it drive, several different concentric circles around that obstacle, and that will clean it up. That's on that other one you showed.
Yeah, I'll scroll down and get that.
So I don't know how, you've got the seat down at the bottom around that circle. You just come up to the thing and then drive around instead of getting real complicated like that. Just simply, as I say, just drive in circles around that thing, and that'll clean up all that area there.
Oh, come on. That was fun math to figure. Oops.
Yeah, but look at that picture. I didn't know how your vehicle's going to do that, but I guess it'd be interesting if you can make it do that right now. Go out and take a picture of it doing that, so we can see how that works, and then
I'll, I'll show you the math or show you the plot of what that looks like. We'll see. That's part of the testing. I did try it. So there's the circle and the different paths. So the blue path goes to the top and the orange, green, and red path go to the bottom. And there's a script in here that calculates which is the shorter path. So anyway, one of the learnings around dealing with obstacles in the path. Ultimately, it might just be easier to drive the whole thing and capture the mission and repeat it instead of all this math. But it's been fun trying it. So that's the state of path coverage planning or coverage path planning, whatever. Headland. I'll have to remember that. Tested the path on a small scale. Before I could test again out in the field, I had to rewire my USB because, well, I'll just show you here. I have this USB, I don't know, what do you call that? USB hub with a number of different ports. And there's a 12-volt power cord that comes out on this end to give it extra power that's, over and above what it would get from the laptop. And a daggone mouse chewed it. And you might say, well, how do you know that our mouse chewed it? It's because when I cover this up, I had put down, like, on the top, there's a tarp, and then there's a insulating bubble wrap kind of thing. And then there is some soft cloth. And boy, that mouse liked that cloth and chewed it up and made a little nest. And I was only gone a couple of weeks and he had already made a nest in there. So, and then while I was messing around with the tractor, the mouse actually came back and it was like hopping around. I'm like, get the heck out of here. So anyway, I had to repair that. And then I did a little testing and I had some errors having to deal with a couple of the USB ports. One of them is this USB to TTL that I use to get command velocity data over into the microcontroller, which is plugged into this port. And in that process, I'm like, daggone it, there's 17 log files. And I was going through the log files looking for errors. And I'm like, this is tedious and I'm not sure how valid that's going to be. So I have a script that I put out on GitHub that basically I use to put some search terms in, and it goes through all of the log files in, whatever path you put it. And I don't know how, it's probably pretty small. But in my ROS latest folder, there were 17 log files. It'd probably be, depends on, I mean, plus or minus depending on your particular setup. But anyway, that runs and then spits out something that looks like this, because my latest error is getting this error. I've never seen that before, never had to deal with that before. And I have two devices. One is a Teensy 3.2 plugged into this USB port, and it provides left odometry data. And I've got another microcontroller to give me right odometry data, and that is spitting out that error. So anyway, it tells you, hey, I found this error in that log file. And so then I'm able to open up that log file, which is right here, and it doesn't give me any. I do know that I'm not getting meters traveled data because from the start to the finish of this log file, meters traveled still 0. So yeah, that's a problem. I only use this data if I lose GPS signal, but it's still, that's a problem that I need to fix too. So that's where I'm at on that. The last thing I was just going to mention is as I was testing and dealing with these serial ports, I decided to update my user interface. This is my GUI that runs on the laptop. It makes it easy for me to start the launch files and start the ROS bag record and to stop the ROS bag record and whatnot. So that's why I had the GUI. I also had the GUI to, let's see, can I make this bigger? Anyway, there's 3 green symbols down here. Those are little icons. When the machine starts, those are all red. When it gets RTK GPS, it goes green. And now when these 2 serial ports are working in this particular code, I set the serial status to 1. If that's successful, guess I should set it to 0 when if it's not successful. Yeah, there's an improvement. And then I publish that data in this serial status array, and then I'm able to then pick that up and display that in the GUI. So that was adding a little bit more information to the GUI is the other thing I just wanted to share. So that's what's been going on with me. When we get off here, I'll go back out and I don't know. I might be able to get to the reboot button on that Teensy. If so, I'll reboot that, maybe pull the USB cable out, plug it back in, and see if that fixes my I2C error. Boy, I hope, because otherwise I have to take that damn thing apart and see if the Teensy has gone belly up.
It could be your mouse was chewing on those wires too. So maybe you just got some of the small wires running around in there that somebody was chewing on.
Yeah, I'll have to inspect this. I didn't inspect that cable. That's definitely, that's the first thing I should do. And take another cable with me when I go out there. Because it could still be a cable issue, right? But
Yeah, or possibly your connectors just popped off your sensor board or something. So
I just wouldn't think I would get a detailed message like I2C is screwed up. But anyway,
what was that message again that it said, or just simply said it can't talk I2C? This is error. I was thinking if you pull up while you're out there playing, pull up your the stuff in Linux. So what is it? Dmessage, because dmessage will tell you those DMESG, I think is what it is. Or you can say dmessage dash dash follow or something like that. So as stuff changes, there's an E in there somewhere. No, DMESG.
you'd think I'd used that before. I have. I use it frequently. Why isn't that coming up?
Well, just because you haven't spelled it right yet. DMESG. G. There you go. So there it is. And that if you're getting I2C errors, I think it'll pop up there and tell you something about it says I attempted it, it didn't work or whatever. That might be, that might give you more information there.
Would you think it's I2C, capital or not capital?
I don't know.
It's not capital.
Put a dash I, say grep dash I, and then it says ignore case.
Space dash I or
Just like that, yeah. Is this talking to your running machine right now, or is this something else you're looking at?
it's the tractor machine. It's the laptop where if there was an error message while I was running before, it would, but I
So,
don't know
so,
if
so
it,
so it's not necessarily trying to talk I squared C right now, the way it's sitting.
no, yeah, I guess that could be.
So
No,
I
it
assume
is
you have,
not.
yeah, you'd have to fire up a launch file and it'll start talking and then see if you get errors popping up here.
Yeah, okay. I can try that too.
And, you're talking about searching log files, it might be handy to figure out some way to search this file. If you identify certain things that come up as errors, you just something that says, tell me what the errors are in D messages, just have a list out some things here. That might be a quick way to just try to, instead of trying to dig back through this stuff, because there's tons and tons of stuff in this file.
So anyway, a little bit of progress, but
There's also various commands for I squared C that you can run, and I can't think what they are right offhand, but there's, ones that'll tell you what devices are on the bus, and I, actually I can't remember what any of the commands are, but there's various commands that will tell you something about I squared C, just Linux commands that tell you if the interface is running and things like that.
I have to look at my so if I pull up I'm just pulling up, I'm still sharing, right? This is the code that's running on that teensy that's complaining. Um, if I just do a search on that,
Is that the message right there where it says in NH log warn I squared C error? Yeah, that one. Is that the one you were seeing?
yeah, so request result in transmission. So I programmed that error message. Uh,
Yeah, so your code there says it requested to send an I squared C message out to your sensor and it didn't get the response back. So it's down at that level, I think, is where you've got a problem. So it looks like the wiring between your teensy and your sensor is what that tends to indicate to me.
and the sensor is that magnetic deal. It's got that crazy amount of resolution. I think AS 5600 or something. I don't think I have any picture of or anything about. Yeah, I don't show what that looks like here. Um, it's an ad I should put here too. Yeah, so maybe that was a mouse or just soldering and vibration
Or your magnet fell off. Well, no,
or
it still should be able to talk to the sensor whether your magnet's there or not.
yeah, that's helpful to debug that.
So yeah, I'd look at the wire in there and see if they've got anything funny going on.
Okay, so might be popping off that wheel and popping off that sensor.
If you happen to have an extra one of those sensors laying around, you could take it with you. So if you could unplug the current sensor and plug your new one in, just to see if it'll talk to a sensor, because it could be the sensor has gone bad too. That would be another possibility.
Yeah, you know me, I'm just reaching over here. I probably have I probably have a bag full of those damn things.
Yeah. Does it have the right connector that'll plug right in, or do you have to You'd have to
I'd,
monkey around with it.
yeah, I'd definitely have to monkey around with it because to get that magnet, it looks like that. I had to get the had to 3D print it into this thing because you have like 1 millimeter to 3 millimeter gap between the magnet and the actual sensor, and yeah, I think I'm going to be pulling that apart today.
Well, I'm not suggesting playing with the magnet. I'm just saying unplug the wires from the sensor and plug them into like that board you had in your hand right there, just to see if the communication, if it can talk to it or not. Unless those sensors, if there's no magnet at all, is that an error? Or does it just give you a reading of 0?
Yeah, I don't know for sure, but my suspicion is it just gives you a high
Yeah.
value or
But
low
my
value.
thought is just replace it just to see if the electrical stuff, to verify the sensor is working. And if not, if the new, just an extra sensor plugged in is working. And I don't really care about all the magnets and the angles and everything at this point. It just looks to me like the teensy is trying to talk I squared C and it can't. So it's just that I was just thinking that might be a handy thing to check while you're there. Just lay a sensor there and plug it in and see if it can talk to that one instead.
It's a good suggestion. So
Then maybe buy some mouse traps.
that's
Also
yeah,
get those glue traps, you just lay them on the ground and they walk across and get stuck in them. And it was an interesting point when I was cleaning out my garage. I found a bunch of dead mice on the floor. I had a motorcycle parked, and over the years it had leaked out oil or something on the floor. And I don't know if they're trying to eat the oil and they died, or if the oil got sticky enough that it acted like the glue trap. So it looked like, years ago there were several mice that got stuck in that, and I just found their remains there. So, but yeah, you can just get a glue trap, and then when you catch them, you can throw the whole thing in the trash or whatever you want to do with them at that point.
yeah. I mean, I have like a little covering over the tractor so it doesn't physically get rained on, but it is out in the open. And I had a gas can sitting there as well with, a gallon or two of gas in it and a black spout sticking up. And the damn mouse was gnawing on the gas spout too. Like, I was like,
Oh,
why?
so this is not park. I was thinking this was parked in your garage, but this is actually like sitting out in
It
this
is,
guy's.
yeah.
Okay, so that's so I don't know if mouse traps would do much good other than, yeah, you just it reduce the number of mice around, I guess would help out quite a lot.
Yeah. So it's not in a sealed building or anything. It barely has coverage.
Yeah.
That's all I got.
Okay, that's all I got too.